Hello, my name is John Schneider. I'm here representing myself and Mr. Chris Brown. We developed a technology for the United States Marine Corps for the forward deployable bases as a power management system. In complex operations out in the battlefield, energy is key. Energy is what keeps your battle going. And sometimes logistically, fuel can cost 10,000 times the amount that it would cost normally. So a gallon of fuel could cost you $400 to get it out to a forward operating base, not including the loss of life that could occur taking it out there. Me and Mr. Brown, we decided that we were going to come up with a technology that would allow the most efficient use of energy on the battlefield. So what we did was we looked at the problem. What is the problem? The problem is, how do you get it out there, or what do you do? Well, we know that there's other ways we can generate energy: renewables, wind, solar, various other ways. Only that is, are we using the energy the most efficient way possible? So is it more smart to run 3 generators at quarter speed, 1 generator at full speed, or 2 generators at 50%? If you have a myriad of different solutions that can solve that problem, but something has to control everything. Something has to monitor everything. Something has to report everything. Not only is this will save energy, it also helps the battlefield commander in understanding what he's going to need logistically to fight the battle. So what we did was we made a scalable system that's used for controlling energy, producer and consumer, whether smart or dumb, and ways of storing it through batteries, capacitors, flywheels, all different types of ways of storing energy, so that it can be usable, so that we're not burning off good energy, heat through heat dissipation, to combat wet stacking on generators. So you have this system. It sits there. It's like a really smart traffic cop, to where it's a scientific traffic cop, to where it's going to sit there and think about what is the best way to use it. So if I have, let's say an electric motor that has to kick on for the AC unit, well, maybe you could, instead of just going full bore and kicking it always in and using a bunch of energy, maybe it's smarter to do it over a small period of time, to where it ramps up slowly and uses the energy more efficiently. So this thing goes all the way down to that level of how it's going to be used. Let's talk about how it's going to be produced. With generators, you're going to find out that generators are going to become more, let's say, inefficient as the run time on the engine occurs. Why? Maintenance, other things that occur that would hinder its premium optimization. So the system would not only control how they use it, controls how it's produced. Maybe on that generator that maintenance needs to be done. So we'd send an email or something to the battlefield commander or the S3 or where it would be and say, hey, look, it's time to time to change oil in the generator there. And not only that, we do mean time of failures, what have you. It could go endless. So looking for somebody to come, we had a working prototype at one time, to say in the virtual realm, where we took 4 generators and we manipulated different loads on them to see if it would optimize itself out, and it did. So what we're looking for is people to come on, work with us on it, maybe further this and privatize it to make it work for the commercial industry, because if we're all sharing the same energy and we all use it the most efficiently, then there's no such thing as peak power requirement. So there will be no peak power. We'll all share the energy. So it could help. Thank you.